Question number 5. Lucy bought a car for $23,000, so that's our starting value, right? It is depreciating, so 1 minus 0.17, 17% per year. When will the value of the car be $10,000? So X is my years, right? And Y is my value. So it wants to know when Y is $10,000. How many years will that be, right? 0, 0, 0 times 1 minus 0.17, you guys, 83? 80.83. So first things first, divide both sides by 23,000. So 10 divided by 23 equals 0.83 to the power of x. Okay, now when a variable is in the exponent, we know we have to do a log to get that variable out of an exponent. So we need to take the log of both sides. So we need the log of 10 over 23 is equal to, now that x comes down, x times log of 0.83. The log of 0.83 is just a number, so I'm going to divide both sides because it's x times there. I need to get x by itself. Divide both sides by the log of 0.83. And that should give me my approximate years. I'm betting it's not going to be a wonderful number. Again, I like to wait till the end to put all the numbers in, even the fraction, because I think the calculator gives you a better answer because you're not rounding every time you're doing something. So we're going to take the log of, and then I have to put, oh no, I can just do this as a 10 divided by 23 in parentheses, then divided by the log, make sure I'm putting in the right numbers here, you guys, that whole thing divided by the log of 0.83 parenthesis. And what do I get? I get an error. That's awesome. Let's see, what did I do wrong? Oh, looks like I put 2 decimals in. That was a dumb mistake, but that happens. Clear. So what do I get now? Yay! 4.5 years, approximately 4.47. 4.47 years, okay? But if x is standing for years, you might want to say, if it was like a real world situation, like 5 years, depending on if that breaks down to months also, okay? Because it's an annual thing that we're doing here. But that's your best decision would work for that. What's next? Number 6. I told you to skip number 6, but let's talk about it in class because there is one question on the test that is finding the inverse, which I completely forgot about, but it's not hard, it's super easy, but we'll skip it for now since I told you to skip it. Number 7, public service utilities uses the equation y equals a plus b log x to determine the cost of electricity, where y represents the cost and x represents the time in hours. The first hour of use costs, so that's a point, the first hour of use costs $7.44. And the third, there's another point, hour of use costs $18.36. Okay, so I have 2 points. So I bet I can make 2 equations with 2 unknowns. Determine the values of A and B in the model. Okay, so my first equation is 7.44 equals A plus B log 1, right? And my second equation equals my y, 1836 equals a plus b log 3. Okay, so let's do this one. This one is going to be, I think, well, this is 0, right? The log of 1 is just 0 because it's 10, it's base 10 to what power equals 1? That's 0, okay? So that makes b 0. Oh, so actually a is 7.44, right? And the log of any base that's equal to 1 is going to be 0, because anything, that's one of our rules of exponents, right? Anything to the 0 power is 1. So that was a lot easier than I thought it was going to be. So now we have 18.36 equals a plus, oops, but instead of a, I'm going to put 7.44 plus b log 3. Okay, and log 3 is a number also, but it's not one I can easily do in my head. So let's just start taking away from the outside to get b by itself. So subtract 7.44 from both sides. And, oh God, I hope these are 2, 7, 13 minus 4 is 9, 1092 equals b log 3. And then just divide both sides by log 3, and that'll be b. So b is actually equal to 10.92 divided by log 3. 10.92 divided by log 3. 22.89. Okay. Cool. So we found A. Whoops, sorry guys. And we found B. And the next step, I re-put A and B back into my equation, and it wants me to solve for the x-intercept. Well, of course I know that the x-intercept happens when y is 0, just like the y-intercept happens when x is 0. Okay, so I'm going to put that in, so all I have to do is solve for x. Really quickly, the first thing I'm going to do is I'm going to subtract 7.44 from both sides, and then I'm going to divide it by 22.89 to get the log of x. So I will have log of x is actually equal to, let's see, I got negative 0.325 approximately. Okay. Now I only have log on one side, so remember there's no base, it's base 10, so 10 to the negative 0.325 power equals x, right? That's my funny heart. My funny heart. Sounds like a movie or a song. That ends up being, I did this in the calculator, 10 to the negative 0.325 is 0.473 approximately. Okay. All right, what's the next thing? It is asking use the model to find the cost of 65 hours of electrical use. Hours is the x, so I'm going to just erase some of this stuff, you guys, because I don't want to lose my equation. Oops, which was what I just erased. That was weird. So 65 hours is going to go in for x, right? So let's see. And then we'll just solve for y, so it wants you to do it backwards, which is going to be a lot easier than the other way we did it. Okay, so that was 7.44 log of x, but instead of x, we're going to change x to be 65. And log of 65 is just a number. So if you just type that into the calculator, we should be able to do that because it's all numbers. 7.44 plus 22.89 0.9 times log. And I don't have to put anything in parentheses here because times comes before adding, and the calculator knows that. Log of 65. What do I get back? Hopefully it's a good number. Okay, about 49, what was our Y? Dollars? Oh, the cost of electricity, $49 for 65 hours of use, right? So Y equals approximately $49. Although I guess we could have rounded to the pennies since it's money, for 65 hours of use. If a customer can afford $15 a month for electricity, how long can he or she have vehicless electricity turned on? So let's see. In my younger days, I've had the electricity turned off. It is not fun. And then if it's at night, you're so bored because you have no lights. $15 is Y, right? Y is money. So we're going to solve it again this way. 0.44 plus 22.89 log x. So again, subtract 7.44 and then divide by 22.89. So 15 minus 7.44 divided by 22.89. And I get approximately 0.3303 is equal to the log of x, right? And that's log base 10. If I only have the log on one side, I take the base. The other side is my exponent, 0.3303. And if I put that into the calculator, I get 2.14 approximately. So she can only have the lights on for 2.14 hours per month. That does not sound like fun to me. What's the last, is that the last question? Was that the last question for that number? Yep. I better stop this one here, and then I will do, oh, that's it. That's perfect because I said don't do 8 either. So 3 videos, not too bad. We'll do another practice test tomorrow, and then we'll have our test Monday. We're only going to have hour classes, but let's see how much we can get done. Okay? Thanks, you guys.